Astronomy Days. I am Carrie. I'm an educator here at the museum, and we like to start every program with a fun icebreaker question, and y'all are going to like this one today. So we are going to be talking about Venus, and on Venus, it's so hot you can cook a pizza in 15 seconds. So tell me in the chat, what kind of pizza are you going to cook on Venus? So I'll just say mine out loud. I will do a mushroom jalapeno pizza because that's my favorite. And while y'all are thinking about what pizza you're going to cook on hot Venus, I'm going to go through a quick Zoom tutorial just to make sure we all have an amazing viewing experience. So we do have live captions for this program. If you'd like to use the captions, at the bottom of your screen, you'll see it says closed caption. Click that and click show subtitle. Then the subtitles are going to look like that, and it'll be at the bottom of the screen. So we want you to have the best possible view. So you want to go up to view options and click side by side mode. That takes our videos and puts them next to the slide so that nothing is obscured by that. You can also change how big the videos are versus the slides with this bar in the center. You can slide that back and forth. Lastly, we want to hear from you in the chat. So ask your questions. This is going to be a really fun program. I'm sure you're going to have lots of questions because I know I've been in a lot of programs and so many people have been asking questions about Venus. So today is where we're going to get them all answered. So put your questions in the chat. I just want to make sure to remind everyone, please be a good digital citizen, be kind and respectful to each other and to me and the speaker, and try and keep on topic. With that, I am going to check the chat here. And what do people want on their pizza? Pepperoni, cheese, pineapple. I like pineapple too. Olives and peppers. Oh, we got a lot of pepperonis. Pineapple and jalapeno. Ooh, Skelly, that one sounds good. Dairy-free extra cheese. Nice. Fresh basil and tomato. Now it is lunchtime. So now that we're all hungry, I'm going to go ahead and introduce our speaker. So Doug Lively is a NASA JPL Solar System Ambassador. He is also with the Raleigh Astronomy Club. And I've been working with Doug for all 14 years that I've been doing astronomy days at the museum. So Doug was there when I started. So he's been doing it even longer than me. So he is just an integral part of this event. So everyone, please welcome Doug. And Doug, you can take it away.
All right, thanks, Carrie, and thanks everybody. Just want to do a sound check. Can you everybody hear me?
Yeah, sounds great.
Awesome, great. So I'll share my screen in just a second. But I just gotta say, Carrie, you made me really hungry. Hearing all that pizza and everything, that sounds delicious. And it is lunchtime, but maybe you guys can kind of hold it for a little bit as we have a little fun talking about the Venus, Earth, evil sibling. So I'm going to go ahead and start my share here. And as soon as you guys can see my screen, maybe you can just give me a thumbs up or whatever.
Yeah, it looks great.
Awesome. Okay. So, when we think about Venus, everybody talks about Mars. Mars. That's all we hear about is Mars this, Mars that, people going there. And poor little lonely Venus is kind of sitting out there in the cosmos and, not getting a lot of attention. So, it's just like in any family. You've got one sibling gets more attention than another sibling, and they get angry, they get hot, they get mad. And so Venus is hot, it's mad, and maybe we should be giving it more attention. But today we're actually going to maybe talk a little bit more about the science behind Venus and talk about maybe why Venus is really hot. So I hope you'll just sit back, enjoy. Don't be afraid to ask questions. And, even afterwards, if you have a non-Venus related question, something related to astronomy or anything else, don't hesitate to put that in the chat. If I don't know the answer, I'll just tell you, I don't know the answer. We don't know the answers to everything. And that's why we're studying Venus. So let's talk about Venus just for a second. And let me just give a quick, all right. So before we talk a little about Venus, I want to talk about our solar system, because our solar system is really important to understanding really this interesting relationship that we have between Venus, Earth, and Mars. And we really do have a unique solar system. If you look at any of the exosolar systems that have been discovered, we've discovered about 4,800 exosolar planets. So we're beginning to look at a lot of star systems in the way they're organized. But if you look and compare that to our star system, our star system is unique among all of them. And the reason why it's unique is because all of the large gas giants, which would be Jupiter, Saturn, Uranus, and Neptune, they're all in the outer portion of the solar system. And the rocky planets, Mercury, Venus, Earth, and Mars, are all on the inner portion of our solar system. And our Earth sits in a really interesting place. If you look at this blue band, this blue band is known as the habitable zone or the Goldilocks zone, depending on who you listen to. And the Goldilocks zone is really this place where on the inside of it, it's too hot. On the outside of it, it's too cold. But just inside, it's just right, just like in the book about Goldilocks. Earth sits in that really comfortable zone where it's conducive to life. It's not too hot. The sun, radiation coming from the sun doesn't affect us as much. And so Earth is perfect for life. And of course, life flourishes on our planet. But just inside and just outside the habitable zones, we have Venus on the inside and Mars on the outside. So Mars literally is very cold and very arid. It doesn't have much of an atmosphere. But we do think, we're doing continual study. We see signs of water, possibly life on Mars that could have been on Mars at one time, but it's just not there now. So it needs more study as well. On Venus, very different. It's very dense. It actually has a very dense atmosphere, and it's very hot. So, but it looks like most of the water has been boiled away or has been boiled up into the upper atmosphere. So we don't have a lot of water to inspect on Venus. So that's a way that Venus is similar to Mars. Also, we have an amazing magnetic field that protects Earth. So you can see we have the sun here on the left, and we have these magnetic lines of flux coming between Earth and the sun. And then our own Earth generates its own magnetic field, which when the sun sends out radiation and sends out particles and the aurora that we like to see, especially those who have been up north have been able to see that. Our magnetic field is generated internally in Earth, and so it basically protects our Earth. It looks like a little like a spider if you kind of look at that, and Earth, in a sense, has that spidey sense. Once something is projected from the sun, our magnetic field kicks into action, and protects us from that radiation coming from the sun. Venus, on the other hand, has kind of like a swallowtail shaped magnetic field, or kind of cup shaped. And it's inductive, so it's not generating its own magnetic field, and we need to understand why that is. Mars is very similar to Venus in that respect. It also has a cup-shaped magnetic field, but this magnetic field for Earth really does a lot to protect life on our planet, keeps us from being burned up by the radiation, and so it's a wonderful thing to have. That's something that we need to understand about Venus and about about Mars. So let's talk a little bit about our sibling, Venus, and let's talk about some of the similarities. When we look at the volume of Venus, it's about 85% the volume. Now, the volume is, if you think of this cup right here, it's how much liquid you can pour in the cup. So essentially, that's everything that you can fill Venus up with. Is really roughly about 85% the size of Earth. So that's very similar to Earth. When you look at the mass is really kind of that accelerating mass, which basically helps us understand how heavy or something is. Even though mass is not a measure of weight, it is a measure of how much energy it takes to move something along. And so the mass of Venus is 81% that of Earth, almost 82%. So it's very, very similar to Earth. Unlike Mars, which Mars is really only about half the size of Earth, half its mass, half its volume. So it's much smaller. So the gravitation isn't very strong on Mars. On Venus, the gravitational pull on Venus is almost 90% of that of Earth. So it's very similar. If you were able to stand on the surface of Venus, it would be very much like standing on the surface of Earth. With respect to gravity, we're going to talk about some differences with respect to the surface of Venus in a minute. But so basically volume, mass, and gravity make Venus very, very similar to Earth. Another similarity is escape velocity, and that's very important because if you want to launch a rocket ship off of Earth, you've got to travel about 7 miles per second just to get off the surface of the Earth. In Venus, the escape velocity is roughly about 6 miles per second. So it's very, very similar. So similar kinds of technology would get you to the surface of Venus and off the surface of Venus. Very, very different than Mars. Of course, Mars is much smaller, so not as much needed for escape velocity. The orbital speed. Now, the orbital speed is the speed that it takes for us to circle the sun. And so Earth is traveling roughly about 29 kilometers per second, Venus 35. So it's very close in orbital speed. And then a year on, now this is a little bit of a difference. A year on Venus is 225 days, whereas on Earth it's 365 days, as we all know. But if you're working and you're working on Venus and you're waiting for your yearly vacation to come around, it comes around a lot faster than it does on Earth. So you might want to consider, working in a laboratory on Venus. All right, so let's go and now maybe let's talk about some of the differences. So very important, Earth has an axial tilt of 23.4 degrees. And so when we look at Earth in space, our Earth is tilted about like that. And so that's it's really actually one of the perfect tilts for a planet to have for life. When we look at Venus, Venus is tilted at 177.3 degrees. That's almost 180 degrees. So its south is pointing north and its north is pointing south. So that's very different. But we could still live on a planet like that, But that's really what Venus is tilted like. We'll talk about why that might be in just a minute. The surface pressure. Now, the surface pressure is one of the things that makes life on Venus very, very difficult. On Earth, it's about 1 bar. And that's what we experience regularly on any day is about 1 bar of pressure. And so that's very conducive to life on Earth. And that's if you're into more physics and you know that as 101.3 kilopascals. On Venus, the pressure is crushing. That's at 93 bars. Now that doesn't sound like a lot, just only, but it's almost 100 times the pressure here on Earth. It's 9.3 million pascals. So it's very, very heavy. So Venus has that crushing depth, that pressure. And we'll talk a little bit more about that as we go on. So you really wouldn't want to be on the surface of Venus as it is now, because you really wouldn't be able to stand. Another thing about Venus is that one day on Venus is about 243 Earth days. So that's a long time. Now, if you were working on Venus and your vacation time came around and you had 2 weeks worth of vacation, you might want to take that because that means you wouldn't go back to work for almost 10 years. So that would be fun. Or if you're out on school, school break, whether you had like a traditional program and you were out for summer vacation, which lasts about 90 days on Earth, that means you wouldn't have to go back to school for 90 years or almost 90 years. Or if you're, if you're on taking that 2-week vacation, you wouldn't have to go back to work for 10 years. So woohoo, it'd be a lot, you might want to work there instead of actually working on Earth. Now, when we think about the atmosphere of Earth, so both Venus and Earth have very dense atmospheres. So it's great. That's conducive for life. But the problem with Venus's atmosphere is it's 96.5% carbon dioxide. So that's prohibitive for us for actually breathing. We wouldn't be able to breathe that. Whereas on Earth, we have 78% nitrogen, 20% oxygen. Many of you have recalled this from high school, versus the 96.5% of CO2 and only 3.5% of nitrogen. And then we have some other elements like sulfur dioxide, that's SO2, and argon. So it's in terms of the gases, it's not conducive for us to breathe. In fact, on Venus, one of the big differences between Earth and Venus is that on Earth, most of our carbon is solid. It's in rocks, it's in liquids, it's not floating around in our atmosphere. On Venus, though, most of the carbon is in the atmosphere, and so that's a very bad thing for the actual planet itself. We'll talk a little bit more about that in just a moment. And then finally, the surface temperature. On Earth, our surface temperature on average is about 58 to 60 degrees Fahrenheit. So that's very comfortable. But on Venus, the surface temperature is on average about 876 degrees Fahrenheit. So that's pretty hot. That's enough to melt lead, okay? So you literally have rivers of molten lead on Venus. It's quite possible. All right, and finally, the rain. So when we think about rain, it actually rains on Venus, but instead of water, H2O, it rains sulfuric acid. And if you guys don't know what sulfuric acid is, any liquid car battery has an electrolyte in it called sulfuric acid. It's very corrosive. If you ever get any on your skin, it just begins to melt your skin immediately. You don't ever want to come in contact with that. It's very corrosive, and anything that is subject to this sulfuric acid rain actually would begin to disintegrate very quickly. Our rivers are mostly water on Earth, but on Venus we see rivers of lava and molten rock. So it's very, very different kinds of rivers. But Venus does have very similar terrestrial features. They have mountains, volcanoes, valleys, and plateaus. So in that way, it's very, very similar. It's just that the atmosphere and the surface are very caustic for human life. So, and when you're thinking about Venus, it's one thing to ask, why is Venus that way? But today I want you to ask another question. The question I want you to begin asking yourself is, why isn't Earth like Venus? What's going on Earth that prevents Earth from being like Venus? Right? So let's go to the next one. And finally, I want to talk a little bit about surface winds. Our surface winds on Earth are about 7.5 miles per hour, whereas on Venus, they're roughly around 186 miles per hour. So that's a really strong, hurricane, roughly. So you definitely have those hurricane force winds on a regular basis. Magnetic field. Our magnetic field is very strong, so that means a lot of the radiation coming from the sun gets blocked by that magnetic field. Venus has a weak magnetic field, which could actually relate to its problem with overheating. We'll talk about that in a minute. And then it spins. The spin on Venus is west to east. So on Earth, our spin, the way the Earth spins, it spins counterclockwise, east to west. So that means when you go out tonight and you go out and you look at the stars, you'll see stars rising in the east and setting in the west. Well, if you were on Venus, you would see stars rising in the west and setting in the east. The sun would rise in the west and set in the east on Venus. So very different. And then very importantly, Earth has a moon and Venus has no moon. And so, in course in school, the only thing you really learn about the moon is, it contributes to the tides on Earth. And that's important for life because it helps mix the ocean, helps mix the oxygen, and mixes nutrients and things like that. But the other thing the moon does for Earth is, number one, it keeps Earth at that 23.4 degree tilt. If you look at the Earth over time, the Earth kind of does this as it's in space. And why that is because we have a moon that sometimes is at the top and sometimes it's at the bottom. And so the moon is always kind of keeping Earth, as it's traveling around, is keeping Earth in this nice axial tilt, which is very comfortable for us. Without the moon, it's theorized that Earth would probably be a lot like Venus. It'd probably flop over like that. because the Earth is kind of squatty. It's not completely balanced. So the moon provides balance for us. The other nice thing the moon does for us is it orbits the Earth. It puts friction on Earth's core, which keeps it molten and liquid and keeps the Earth spinning. So as the core spins, so the Earth spins. So Venus is hardly spinning at all. It spins very slowly. Like, remember when we went back to how long it is for a year on Venus? That's 255 days. So it takes a really long time for Venus to make one rotation. Excuse me, 243 days. My apologies. So it takes a very, very long time for Venus to make one full rotation on its axis. It doesn't have a moon. So the moon doesn't have anything to help it make that axial rotation. The other thing too about our moon is that as stuff is coming in from the inner solar system and the outer solar system, the moon is there as a protector. It absorbs a lot of the asteroids and meteors that are coming in, and it actually gets most of that, whereas Venus doesn't have that protection. So very important to understand that.
So Doug, we have a couple questions.
Yeah, sure. That's a good point.
So Marcel wants to know, could Venus have been like Earth in its past?
Well, that is a really good question. And a lot of people believe that yes, most likely it was like Earth in its past, and something happened to Venus. And we don't know what that is. That's why we need to study it more. But yeah, it's very possible that Venus was very much like Earth, and then something over time happened. We'll talk about a few of those things that might have happened just a little bit later in the slides, but you're very right. That's a good question. And I definitely think you're right on that. It very well could have been much like Earth.
Right. And Janet has a question. Do Mars and Mercury have moons?
Okay. So Mercury has no moons. So we'll answer that question very definitively. Now, there are two moons that orbit Mars, Deimos and Phobos. Now, some people believe that those may not actually be moons, but they might be captured objects, like maybe a captured asteroid or something. The moons of Mars are very, very small, so they can't really affect the core of Mars like our moon affects our core. So they're very, very much smaller. To affect the core of Mars, you really need an object that's about 1/6 the mass of Mars. That's another problem for Mars. If Mars had a moon, then you could have a moon that orbits Mars. Its core would be more warm or hopefully molten like Earth, and it would produce its own magnetic field. The thing is, if a planet doesn't have a moon, more than likely it's not producing or it's not creating its own magnetic field. It has to rely on an inductive magnetic field, much like Venus and Mars do now. So, and that's much, much weaker and much more susceptible to radiation. So that's a great question, Janet, and it's a good one.
I think I have two more. One,
okay, sure.
Janet, it wanted to know, why have only the Russians dropped a camera down to Venus's surface? And is there a U.S. project in the future? And that's a very good question, because that's why our theme is Venus this year.
Yeah,
right?
So
right, Doug?
Exactly. So I tell you what, let's hold that question just in fact, we're about to go there. Hopefully I'll answer your question in that. So let's hold that. It's another really good one, and we'll talk about spaceships to Venus. So.
Okay, awesome. And Jasper has one more about moons. Do we know if any rocky exoplanets have moons?
Yeah, I actually don't know the answer to that question. And I don't think that we have discovered any moons around exoplanets yet. Now, again, this is another area where we need larger space telescopes. Now, JWST, or the James Webb Space Telescope, will not be specifically looking at exoplanets. They're going to be looking at some other important science, like the formation of our galaxy, formation of our universe. So they're not really going to be focused literally on exoplanets. So I think we're going to need a much larger space telescope to go out to do some of these visual observations of exoplanets. And I hope that we'll have something in the future that will do that. But for now, and as far as I know, we haven't discovered any moons around exoplanets. But I mean, think about it. I mean, if they're the size of our Earth or the size of our Jupiter, Jupiter has moons, Earth has a moon. So it would kind of go logically. You would think, yeah, they probably do have moons, but we just don't know that specifically right now.
That's cool. That was an interesting question. So Lindsay wants to know, do you think there was water on Venus at some point?
Yeah, another really good observation there. That's the feeling that NASA has and many other scientists around the world, that there was once, a really robust set of oceans on Venus, and that there is that for some reason something happened that caused that to go away. And we'll talk about that in just also. I'm going to address that in a later slide. So great question.
And Erin wants to know, you talked about rivers of lava. So she wants to know, where did the lava come from?
Very similar to Earth. Venus has a crust, and underneath that crust, there is a mantle. And that mantle is filled with magma. And due to pressures with that magma in Venus, that often has an upwelling, which causes volcanic eruptions, which again, that lava or that magma flows out, turns into lava, and then flows into the depressions and valleys and stuff, making rivers.
Very cool. So we have a few more, but what I'm going to do is I'm going to save those, let you go on, Doug, and we'll take another question break in a few minutes. How's that?
Great. Sure. Perfect. Right. So if you're going to look at Venus, this is Venus actually turning, on its west to east, axis. So you've got, and so Venus, these photographs were actually taken by the Magellan space probe. And what Magellan did was it basically stripped away that cloud layer and allowed us to look at, the surface of Venus with what we call a radar altimeter. And so that just means that the radar is able to sense height and depth. And so in this photo, the lighter edges are going to be the higher surfaces, and as it gets darker, these are the lower surfaces. So we see Venus rotating here. Right? If we were to go to the next slide, this is a colorized, it's a false color version, again from Magellan spacecraft. And you can see the full surface of Venus here. So these dark purple, blue, and green areas are low areas on Venus. And the light areas, the reds, yellows, and the white areas are higher elevations. Now, one thing about Venus is so much volcanic activity and it's so hot that a lot of the surface has just been overwashed with lava. It's actually been completely reformed. But some of these higher elevations that we see here have not been. And so this is, if you look over here on the right, you can see some of those river systems that I talked about. You can see some of these high elevations, Alto Regio, Aphrodite Terra. Over here on the left, Ishtar Terra. We'll talk about Ishtar Terra a little bit later in our discussion. So that's it's a really interesting place. So especially these higher regions, because they haven't been overwashed and reformed by lava flow. And so those would be really interesting places to study what original Venus may have looked like. So that's one thing. Some of these lower areas, we can't get back to the original surface of Venus because it's just been overwashed. But
so Marcel has a clarifying question. Those white swirls are land features?
Yes.
Okay.
Yes, they are. All right, let's move on. Now here's an interesting one. This is Ma'at Mons, and it's snow-capped. Like we have on Earth, we have mountains that are snow-capped, but it's snow-capped in galena and bismuthnite. So those are metals. So on Venus, when it snows, it actually snows metal. So it's kind of, again, not the best environment to stand on, but this is an example of a snow-capped mountain. It's just the snow is made out of these two metals. Here's another really interesting feature that we need to learn more about. This is called a Venusian corona or a corona. And we have this surface feature on Earth as well. But of course, it's a lot on Earth. When we study surface features on Earth, that most of the time they're eroded by the weather. And here we've had the chance of where the weather hasn't actually broken this down, but the corona is basically this circular depression that we see here on Venus. And then this arachnoid, which is basically a fracture, and that you can see these fracture lines going out, radiating out from the center, is where the crust is cracked. Now, how these are formed is that basically we have magma pooling underneath the crust of Venus. And as it pools, it gets bigger and bigger, and then it begins to cool. And when it cools, it sinks. And as it sinks, that's what causes these concentric rings to form on Venus, creating this corona effect, this basically concentric rings of fractures in the surface. But also as it's sinking and cooling, it's creating these radial fractures going out. And so these are structures that we need to study and really understand more about in terms of how they form and everything. But these are some of the things that we see on the surface of Venus. To the left, we have a picture of Ishtar Terra. And on this Terra, there's a plateau called Lakshmi Plateau. And that's over here on the right. You can see that's that circular plateau right here. Now, the reason why this is interesting and the reason why I'm calling this out is that this Lakshmi Plateau is about 2 to 3 miles above the surface of Venus. And just like on Earth, when you're at the surface, of course, that's where your greatest pressure is. When you're up on a mountain, you have less atmosphere and you have less atmospheric pressure. And so it becomes, it's hard for us to breathe up there. But in the case of Venus, that means that the atmosphere is less dense here. And this might be a good place to land spacecraft. And we'll talk about why that is in just a minute. Right. Just one more talk about the magma on Venus. On Earth, many of you guys in school have learned that Earth is covered by a system of crusty plates. We call these crusty plates tectonic plates, and they kind of meet one another in different zones around the Earth. Those zones are called subduction zones. And the reason why that is that, the Earth's crust just doesn't meet nicely like this. Whenever Earth's crust meet, one piece of the crust has to go up and the other piece has to go down. And that's what we see happening on Earth. And of course, we know that in these subduction zones, we have a lot of volcanic activity. We have a lot of earthquake activity, like out in California. We have the Ring of Fire in the Pacific, around the Pacific Basin, which we know has a lot of volcanic activity. And that's what we see on Earth. Now, on Venus, we see a lot of volcanic activity. We don't see those crusty plates like we'd like to see. Now, this is something that we need to study about. We need to understand what the tectonic activity on Venus is. So we don't really have a full understanding of this. But right now, the current understanding is there are no tectonic plates. The crust is continuous around the planet. But what happens is that in the mantle, we have diving or sinking levels of magma. This is magma that's cooled and it sinks. And as it sinks, where it sinks, it causes a pileup and then downwellings in the crust. And then we also have upwellings, which kind of go like this. And that means that we have hot magma coming up, cooling off, and kind of falling off like that. And then where we see that happening is where we theorize all the volcanoes are and where there is volcanic activity. So we know we have volcanic activity. We can see that happening in a very similar way on Earth. So we think that that's what's happening on Venus. But we need to understand more about that. And we do have some space probes that are designed to do that. And I'll talk about those a little later in the slides. Just a kind of a quick look at Earth's core. We understand a lot more about our own core system than we do about Venus. We have a very hot, molten inner core of iron, and then an outer core. And then we have the mantle, which is this orange area right here. And then above that, we have the Earth's crust and, of course, Earth's atmosphere. On Venus, all we know about Venus right now is there's an atmosphere, there is a crust, it's very obviously a mantle, which means that there's an active core. So our understanding of the structure of Venus is really it's in its infancy right now. We need to understand more about it, but we do know it's got something that's active. Something that's interesting about our core is, again, our core is roughly about the size of Mars. So it is very active, spinning. Again, it contributes to Earth's spin, whereas we just don't see that happening with Venus. And so the question is, how do we make that happen? Or how can that core kind of be kickstarted into actually producing maybe more of a beneficial magnetic field for Venus? All right, so why is Venus so hot? That's really what a lot of questions people ask. And again, I want you to kind of ask that question in reverse. If Venus is so hot, why isn't Earth hot? Okay, so that's something to be thinking about. So one thing is that the sun has grown hotter over its own life cycle, and a lot of that radiation has been sent to Venus. Venus is about a third closer to the sun than Earth is. So Earth is basically, Earth is 1, Venus is at 2/3 the distance from the sun. So it's closer. So it's getting a lot more radiation. The big thing is that the CO2 has overloaded the greenhouse effect. So just like Earth, Venus has a greenhouse effect. And then finally, a lot of the water vapor has evaporated or been eroded by the sun's solar winds. So we don't have as much water, at least right now, that we've been able to measure. So on Earth, we have a greenhouse effect. We know that light comes from the sun. Some of it hits clouds and gets reflected back up into space, but others of it gets down, striking and warming the surface. And then it kind of bounces around. Much of the CO2 in the Earth's atmosphere helps that radiation to be reabsorbed and sent back to Earth. But a lot of it does go back up into space. So Earth is able to remain cool because we don't have nearly as much cloud cover. The other thing too is that this produces actually H2O rain. On Venus, very different. We have reflective rays of the sun coming in and striking the clouds and getting reflected back. What does make it back down to the surface does not get reflected back. It's actually contained at the surface, and then it gets basically is reabsorbed as infrared radiation, which has a tendency to heat the surface. So you can see here is we have our clouds. Our clouds on Earth do have carbon dioxide, but they also have water vapor. On Venus, it's mainly carbon dioxide. The sun is striking the surface and gets reflected back to the surface of Venus and is basically reabsorbed. The other thing we have in these clouds, of course, is also sulfuric acid, again, which is very corrosive. Now, the one thing I'm going to give you one little piece of chemistry here. We're not going to go into it deeply, but the greenhouse effect on Venus actually produces sulfuric acid. So on Earth, when water evaporates, it goes up into the atmosphere, it forms clouds, those clouds then condense and rain water back on the Earth. But on Venus, we have basically SO2 going up into the upper atmosphere where it combines with sulfuric oxide. It also takes the remaining hydrogen that's there with sunlight, and with that evaporation and condensation, it actually produces sulfuric acid. Now, here's the thing. We didn't really well understand this process very well until we sent the Magellan spacecraft to Venus in the 1990s. The thing is, once we understood this, we began looking at Earth. And guess what? This is what's happening up in Earth's upper atmosphere. Sulfur dioxide is going up into the upper atmosphere, combining with oxygen to create sulfur trioxide. That then, the sulfur trioxide then combines with the water vapor in our upper atmosphere to also produce sulfuric acid. If you guys have heard about acid rain is really comprised of 3 acids, and one of them of which is sulfuric acid. And this really got NASA disturbed when they saw this, because they realized, well, wait a minute, the same process is happening here. Now on Venus, what drives the sulfur dioxide in the atmosphere is all the volcanic activity. It's pushing it up into the upper atmosphere, which then it can combine with the water vapor to form sulfuric acid. On Earth, though, what's happening is that not so much. We do have volcanic activity, but not as much as Venus. what is contributing and driving sulfur dioxide going into our atmosphere are coal-fired plants that produce energy based on burning coal. And you just can't separate the sulfur dioxide enough from the coal to prevent that. So we're belching a lot of sulfur dioxide up into our upper atmosphere. The fear is that if our greenhouse effect were to tip over and begin exclusively producing sulfuric acid, that would be the end of life on Earth. It would, it's not going to tip back. Once it gets to this point, you don't tip back. So this is why it's really important to understand what's happening on Venus, what's happening on Earth, and how can we prevent this from happening on Earth. Again, the question to ask is, why isn't Earth like Venus? Well, I think up until this point, we've been pretty lucky. But now that we know these things are happening, we need to do something about it. Right. And now we'll talk about some of the orbiters. Here's the Magellan. Actually, I can stop there if you want to answer some questions. Or
yes, yeah, that would be great. I was going to just say, we do a few questions before we move on. Yeah, so let's get to my sheet here. So a lot of people want to know, how old is Venus? And I think maybe let's put it in like context, like how old is the sun and how old is Earth? so we know what that means.
Yeah, so we think that our entire solar system is roughly about 4.6 billion years old. And so if you go to my class on deadly spheres and we talk about how the planets are formed and stuff, but Sun and Earth, Venus, and the outer planets all formed about the same time. And they formed in a nebular cloud. So once the nebular cloud had enough mass to cause fusion reaction, that's how our star was born. And then that ionizing radiation that we got from the sun and also from light caused the planets to condense into solid matter and into more defined spheres. And as those spheres began orbiting around were orbiting around the sun, they began collecting more matter and became actually solid objects like we know today. So roughly, they all formed about the same time. And that'd be about 4.6 billion years ago, if I understand it correctly. All right.
Awesome. Okay. So Jasper has a question.
Okay.
Would the TRAPPIST system's close planets affect the cores of them?
Yeah, that's a great question. And so there's a lot of interactivity when you get two planetary masses close to one another. So the answer to that would be yes, they do. Now, here's a really good example of how we see that in our own solar system. If you look at the moons of Jupiter, the closest moon to Jupiter is Io. And Io is so close to Jupiter that as it orbits Jupiter, Jupiter actually warps its plates and it causes a lot of volcanic activity. So Io itself has no tectonic activity of itself, but it's the mass of that moon orbiting that supermassive planet, Jupiter, that actually causes buckling and it causes all that volcanic activity. So it is possible that two planets could orbit one another and cause a similar kind of event. But let me just say this, you don't want them to get too close, because the closer they get to one another, they begin to kind of stretch one another out. And one of them will eventually wind up breaking apart. And so if they get too close, then they're basically going to break apart and be absorbed by the other planet.
Right, and Aaron wants to know, how did the moon form?
Oh, really good question. And that's another one that I have in my Deadly Spheres talk. It's about how our moon formed. And we also did that.
Maybe Skelly can put a link to the Deadly Spheres talk.
Yeah, we also did that.
Because y'all have a lot of questions about this stuff.
Yeah, and the moon zoom, when we did moon zoom last year, we talked about that. But basically, the theory, something we need to understand more about. But the theory is that there was a planet about the size of Mars that shared an orbit with Earth at some time in Earth's geologic past. those two planets collided. So Earth actually collided with a Mars-sized planet. The Mars-sized planet was absorbed by Earth, and the debris that came from that collision got kicked up and circled the Earth. So at one time, Earth may have had a ring, but very, very quickly, all that material was kind of absorbed into a little sphere that we call the moon. And so it's a very high possibility that that's how our own moon formed. But again, that's why we need to go back to the moon, because we don't really understand how the moon was formed. And so it would be a lot more important for us to go to the moon as well and continue our study. So these are just theories of how it may have happened. I always say stay tuned. Hopefully when we get our Artemis mission and we get full-time bases on the moon, we'll be able to understand that more. Okay.
All right. And Becky wants to know, is it possible that as the sun got older, it pushed the habitable zone out, causing the water on Venus to evaporate?
Oh, that's a really good one. And I'm going to say yes. And because as the sun begins to expand, it kind of loses that, in this case, our sun has become hot. So it was very, very, I think it actually got when it was very, very, much smaller, it wasn't quite as hot. As it got larger, it got hotter. That habitable zone would have moved further out. And so, yeah, Earth may have not had life, and it might have been Venus was the place to be. But just like you said, it just moved out. And so now Venus is kind of like not in the neighborhood anymore. So, yeah, great question.
All right. And Janet is asking, if Venus has a core, why not a magnetic field?
Okay, excellent. The reason why is we do not believe that the magnetic field, that the core itself is spinning, or at least spinning as fast as it is on Earth. So the magnetic field is either very, very weak or not there at all. So the trick is, how would we get that core to begin spinning? So there's some things to think about. We'll talk about that a little bit later. Good question.
And then Shani has a question. Why are the names of things on Venus Indian names instead of Greek or Roman?
Well, actually, some of them are also, not only are they Indian, but some of them are also Sumerian names. I'm going to say that there may have been a little misogyny at NASA because they're mostly names of females. So we do have Aphrodite Terra, which is Greek, but we have Ishtar Terra, which is Sumerian and Indian. So yeah, but they did name Mars has always been considered the kind of the warrior planet, kind of the male planet, and Venus has always been considered the female. In the Greek mythology, Venus was female, and so they had a tendency to name all the features after feminine names versus other planets.
Okay, well, that's pretty cool.
Yep.
Okay. All right, Jasper. Here's this will be the last one for this question break. Well,
then I'll need to move quickly. So yeah.
With the TRAPPIST systems cores interacting, keep the magnetic fields up and running, but not too close to cause devastating effects to life.
And I think that's a question that needs more study as we begin to study those systems more clearly. What we do see is, especially when we consider Earth and Moon, that interaction does keep our core spinning, and so that's a good thing. It could very well be that those planets, if they do orbit around one another, would keep an active magnetic core.
All right, cool.
Excellent, great question.
Thank you.
All right, let's go on. These are some actual pictures from the surface of Venus. The only pictures that we have from surface of Venus are from Russian spacecraft. Now, the Russians have put a lot of money into exploration of Venus. They kind of felt that, hey, the US is spending a lot of dough on Mars, so we'll go to Venus. The thing over here on the right, I have a picture of the Venera 13 spacecraft. And so Venera 13 and Venera 14 were the most successful spacecraft. They're the ones that actually made it down to the surface of Venus and actually were able to give us pictures. There may be a few others, but these are probably the most popular. And so here we kind of look at the surface of Venus. It looks kind of green, and these photos haven't been retouched. So this is kind of what it looks like with an actual video from Venus. Also, too, these were like in the 80s, so we don't really have a lot of new stuff from the surface of Venus. One of the interesting things is you see there's like a kind of like some kind of shiny object here, and the thing is that the pressure is so vast on Venus that once spacecraft kind of land on Venus, they actually begin to disintegrate. And so literally these are parts that are falling off the spacecraft. It's beginning to break apart. And so the most video that we ever got from a single spacecraft on the surface of Venus is only about 2.5 hours. And that's not a lot of time to transmit images back to Earth. So this is why but if you look at the surface, if you kind of cover the spacecraft piece up, it looks like a lot like a surface that you might think of on Earth. Here's another one. This is from the opposite end. Very similar. Again, it looks very similar. This is kind of a close-up from the bottom of the spacecraft. It looks like a lot like what we call regolith, which is just basically just bits of rock that are all kind of bunched together. We see a lot of this on the moon. You would look at this, and this might look like something from the surface of the moon. And again, that's it's very Earth-like. We see the same kinds of stuff on Earth. And this is just some other images from Venera, either Venera 14 or this is Venera 13. So for the same images from the spacecraft. Again, just so a few more images before the camera stopped working on that spacecraft. And there's again another kind of a close-up of that piece that fell off and a close-up of the ground. All right, so that was those. Again, the Russians put a lot of work into that, and they've also successfully floated balloons on top of in the upper atmosphere of Venus. So that's something that's very interesting. I'll hold your questions on that because we're going to talk about that really quick. Kind of the next thing that we have really from NASA is Veritas. Veritas is basically going to kind of reconnect with the mission of the Magellan spacecraft. We're going to remap the surface of of Venus, and we're going to begin building 3D models of the planetary surface. And so that's really important. And so there's going to be a lot more sensors on this. It's going to operate a lot like Landsat does, in the sense that we're going to really get those 3D topological pictures of Venus that we just don't have. But we do something very similar to that with our current Landsat satellites for Earth. So this will be a really important mission. So some of the other things too is they really want to try and begin understanding about the planetary evolution. How did Venus change over time? So that's Veritas. That's going to be launched soon in roughly 2028. That's the launch date for it, and so that's been approved by NASA. And that's hopefully we'll be getting off again in about another 6 years or so. The one after that is going to be here's 3D maps. We're going to kind of try to determine geologic history, and then we're going to try to identify rock types through their infrared transmissions, and again charting that surface elevation. The next one that we're going to do is called Da Vinci Plus. And what the Da Vinci Plus does, it's actually going to send a lander to the surface. And hopefully this lander is going to last longer than 2.5 hours. And part of what we're going to do with Da Vinci is, again, as it's descending into the atmosphere, it's going to be taking atmospheric readings. Now, on Venus, when you land a spacecraft, you don't need a parachute. You see, this one has one. But you don't need a parachute because the atmosphere is so thick. You can just use a ablative shield, and it will just kind of like slowly touch down. So we're using this parachute to keep the spacecraft up in the upper atmosphere for a long time, so we can make a lot of measurements as it's actually descending. And you can see this one is really more ovular or spherical in shape, because we want to actually maximize its ability to withstand high pressure. And so
Jasper wants to know, is it going to be made of titanium?
That is a good question. I don't actually know the answer to that. It could be, you don't really have to use exotic metals if you design the structure in the right way. So a sphere is one of those structures that's able to hold and distribute pressure evenly along its surface without being really, breaking. You can kind of try this little experiment with an egg. Hold an egg end to end in your hand and try to break it. Now you can break it, so don't overly do it. But an egg actually has a lot more ability to withstand pressure end to end than it does side to side. So it's the same kind of idea. If we have a spherical object, we can actually withstand a lot more pressure. Could it be made of titanium? Maybe, but they haven't actually published what it's going to be made of yet. But we do want to try to understand how Venus's atmosphere evolved with this one. It also will help us answer some of the questions if there were oceans on Venus. I mean, I think logically we all feel that there were, but this is going to kind of give us that definitive proof. And also try to understand what were some of the past chemical processes that maybe caused Venus's atmosphere to tip over from making water into making sulfuric acid. That's very important for us. We need to understand that because we see that very similar process happening right now in our own atmosphere. And then we're going to get high resolutions of geological features, which we just don't really have. You got to remember, we haven't had a spacecraft on the surface of Venus since the 80s. So it's really important that we kind of get down there on the surface and be able to get some really good pictures. And then, does Venus have plate tectonics? That's just an answer we just really don't know the answer to. Right now, we don't think it does, but it's something that we need to answer. All right. So now, kind of the really cool one is going to be HAVOC, okay? And that is called High Altitude Venus Operational Concept. And what's interesting to know about Venus is, so I've talked about how the surface has all this crushing pressure, but if you go up about 34 miles above the surface of Venus, guess what? It's like Earth. It's comfortable. It's only about half a bar in pressure. The temperature is about 81 degrees, which, I grew up in Florida. 81 is cool to me. So it's a very livable habitat. One of the interesting things is that they don't show it here in this photograph, but the reflection coming up off the clouds of Venus is so bright, you can actually put solar cells above and on the bottom of your spacecraft. So you could actually be getting double the power off of one solar day than you would with just having solar cells on the top. So again, this is just kind of conceptual, and guess what else? We don't need helium to float big ships like this. You know what we need? Air. Exactly, because CO2 is heavier than air, it sinks. So if you just had regular air like we breathe here on Earth, you could inflate a ship to actually float above the surface of Venus. So that's a pretty cool thing. So the first phase is going to be a robotic. So we're just going to put a robot out there to make sure that we can keep this thing up and everything, and that it's stable. Then we're going to have a phase 2, which astronauts will visit and orbit Venus. Then we're going to have astronauts actually descending into the atmosphere and staying on these ships, these observatories, for about 30 days. Then we want to basically get phase 4 is basically to send them into the atmosphere for 1 Earth year. It's kind of hard to read there on that last slide there. And then finally, we want to be able to introduce a human presence, at least in the upper Venusian atmosphere. Now, if you want to think about something, guys, remember this from Star Wars? And this, we thought, well, hey, that's in the future. This is now, guys. This technology we have now. We could begin implementing. You in your own lifetime, especially those of you in elementary school and stuff, could possibly be living on a cloud city in Venus. How cool is that, right? We could be doing this. This is in our current technology. This is not in a galaxy far, far away. This is in an Earth and a Venus close to home. This could be us in just a few years. So we could be doing this. We could be living this technology. All right. Finally, we want to think about what's the possibilities of terraforming Venus. As Venus was at one time a verdant place for life, could we make it that again? And here's some of the suggestions that we might think about. Okay, first of all, we need to vastly reduce atmospheric CO2. We need to understand that. We need to understand that not only for Venus, we need to understand that for Earth, because right now we know that the introduction of CO2 in our atmosphere from our own manufacturing and from our vehicles and from other things is actually driving global warming. For us to understand how to reduce CO2 on Venus is beneficial for Earth. So that's why the number one reason why we really need to go back to Venus and understand how to do this, because this will actually save life on Earth. It does need a moon. We need a moon about 1/6 the size of Venus to orbit around Venus. Now that moon orbiting around Venus could, first of all, remember I told you that Venus is kind of orbiting in the opposite direction? Well, guess what? If you turn Venus right side up, guess what direction it would be orbiting in or would be rotating in? It'd be rotating in the right direction. So we need a moon to not only kind of orbit around Venus to kind of right it back up in the right orientation, but we also need that to kind of help kickstart that core. This is future technology for us to determine, but you know what? If you could go out to the outer solar system, find a few asteroids or so that are about the size, 1/6 the size of Venus, and could move them in towards the inner solar system, you could solve that problem. That again, that's future tech. Again, deorbiting comets, because we don't have any water vapor, we need to reintroduce water vapor into Venus to produce, oceans and beneficial atmospheric gases. So that's another future tech, but we do need to provide water for Venus. So that would be one idea. The thing is that we have comets coming around our sun all the time. So just take one of those comets and provide a mass around that comet to orbit around the comet to kind of steer it into Venus. And you'd be producing beneficial water and atmospheric gases for that planet. And then finally, we need to introduce, once we get to that point and we can begin to cool the planet, we can introduce nitrogen and oxygen emitting extremophiles. These are bacterium that are actually able to live in extreme surfaces like we have here on Earth. We have organisms that live in very extreme, very hot and high pressure environments here on Earth. If we introduce those organisms to Venus and the result of their living produces nitrogen and oxygen, we can begin to replenish that atmosphere. And finally, we would introduce biodiversity, insects, trees, and plants, and sea life once we had that planet cool down enough where we could actually begin introducing things from Earth on Venus. And so that's how we would begin terraforming Venus. All right, so that's the end of my talk. I'm going to stop share because behind me on my view is a view of Cloud City. And NASA, this is actually a poster from NASA, NASA's inviting us all to join them on the Cloud Observatory, because this is, again, kind of going back to that. This is real technology that we can implement now. So it's there. We can do it, guys. It's just a matter of sticking to it and getting out to that planet. And Mr. Musk, if you're listening, don't go to Mars. Go to Venus. That's where the real action's occurring. That's the really cool. That's a neat place to go. Mars is boring. All right, those are my questions.
All right. Well, yeah, I've got a couple questions. So Aaron wants to know, how high could you jump on Venus?
About as high as you can on Earth, because its gravity is very similar.
Okay. And friends, if you have more questions, Kim says, I like Mars. It's not boring. And
Mars is cool. Mars is cool. I'm not gonna disparage Mars.
I know. How many things have been landed on Venus?
Yeah, there's only been a okay, so there's been a handful of spacecraft, most of them from the Russians. I don't actually have the exact count. I speculate it's about 20. Most of them failed miserably. And so we only had about maybe 4 spacecraft that even returned a single image from Venus. All of them were from our friends over in the Soviet Union. And so they have done most of the research. But again, we had a hugely successful spacecraft in the Magellan probe, which basically mapped Venus. We have another one. The European Space Agency has another one that's currently orbiting Venus and doing research there. The interest is high in Venus. And again, I think really, Earth's future is inextricably linked to Venus. If we don't understand what caused Venus to be hot like it is, then when we turn hot, we won't understand how to fix ourselves. And the same way, Venus is inextricably linked to us, because understanding how to fix those problems here on Earth will fix those problems for Venus. Great.
I think yeah. And I think that is such a really important point to take away from this presentation, is that we don't want to end up like Venus, right? So we really have to take action here on Earth to solve some of our problems, so that we don't, we know what happens when you have runaway greenway gas, because there is an example right next door to us.
Exactly.
And so Jed wants to know, when do you think the Sky City is going to be built?
Well, that's a great question, and I hope in my lifetime it will be. But certainly, I don't know how old you are, but certainly in your lifetime, it's possible. Right now, the the Havoc project is in the design phase right now, but probably in the next 10 years or so, we're going to see that moving forward. So really, NASA's being very aggressive about that. They've already defined the phases. They already know they want to put a permanent observatory out there. Once the technology can be proven, then we're going to be putting people out there. Now, Venus is also very important, because with all the high pressure and the heat there, it is very important to study, because you can also use maybe some of the exotic materials. I didn't go into there are some exotic materials floating around in the atmosphere that we don't fully understand. And some of that could be harvested for use in our own technology. So there is a huge technological benefit from understanding Venus, but not only from understanding it, but from the materials that are on Venus that we could actually use.
So I had a question, and I feel like it kind of came up in the chat, but it wasn't a real question. So I'm going to ask it. So as far as human space travel, we've been to the moon, we're planning on going to Mars, and it sounds like we could go to the atmosphere of Venus. Like, where else where else is close enough and safe enough for humans to actually go and visit?
Wow, so that's a good question. Just within our own solar system. Well, let me just say this: star systems, if we can overcome this issue with light travel, the Gliese system is only about 20 light years from us, and it has what looks like a rocky planet in the habitable zone. That would be really interesting if we could do that. If we could get over this issue of traveling faster than speed of light, and figure out how to do that, that would be huge, I think. But terraforming Mars, of course, is another thing that we can speculate about. Some really interesting stuff like on Ganymede, Callisto, and Io. I'm not Io, but Callisto, Europa. These are ice worlds that have water. You could put a sub base on one of those moons. You've got water, if you've got water, you can create oxygen. You can create, once we also solve the issues with fusion reaction, we can begin fusing hydrogen from the water. So you could literally put a base on Europa, Ganymede, or Callisto, and those are also worlds. Those moons are as large or larger than our own moon, larger than Mercury. They could actually be harboring life now. If you go to my talk next on Sunday on Fermi Paradox, we'll talk about some of that. But those are places where we could really thrive as a civilization. Titan going around Saturn and Enceladus, its other moon. There's some really interesting things happen. They think there's an ocean, a subterranean ocean on Enceladus that would be beneficial. Titan has the most exotic atmosphere and exotic things happening. We could literally find another life form based possibly on the silicon molecule or on another molecule or another element. We have other life forms on Earth that are based one on arsenic and some other molecules that are really quite interesting just on our own planet. So why not? Why not? There very well could be other places, and we could thrive there as well in cohabitation with those other species.
Very cool. So Elizabeth says, Doug, you've really sold me on Venus.
All right.
I learned a ton from your presentation. All right. So let me just So Kim wants to know, how big is Venus compared to a human? Well, I would say the same as Earth. Right? Doug went through all those comparisons. It's about the same. And sorry, I'm just scrolling through really quickly. And Shani has a really good question. Isn't it easier to help Earth than to terraform Venus?
Yes, I would think. Here's the thing. When we ask that question, why not why Venus, but why isn't Earth like Venus? So the things that we learn from possibly thinking about how we could terraform Venus, like for instance, removing carbon from our atmosphere. We already know that carbon is in overload right now. So we need to devise ways to remove carbon and carbon dioxide, carbon monoxide out of from our planet's atmosphere. Devising devices and things like that to do that with, I think is really important for Earth. So yes, you're right. It would be easy for us to develop those devices here and actually test them here on Earth, and it would be very beneficial for Earth. Then we could use something like that on Venus to turn Venus's carbon back into a solid, so yeah. Or we can even use that carbon to create carbon nanotubules to build spaceships with. I mean, think about that. It's almost an unlimited source of carbon for us to build future spacecraft with.
Okay, Bill. Sean has a really cool question.
Okay.
Is there a planet that has a moon with a moon?
Wow, I don't know the answer to that question. That's a really good one.
It is a good question. I've wondered that myself.
I'm going to say it's possible. Of all the things I've seen, there's also all sorts of possibilities happening out in just our own outer solar system. I will tell you that there is an asteroid that has 2 moonlets going around it. So that would be a really interesting thing. It's possible, but I don't think it's something that we've found yet.
All right. So are there any private companies working with NASA on Venus?
Yes, there are. And some of these private companies are working to develop these spacecraft. The thing that's great about NASA is NASA does contract a lot of their design, research, and a lot of their materials development out to these companies. So, places like Lockheed Martin, Boeing, of course, now with Elon Musk's organization with SpaceX, they're all working with NASA to develop landers and stuff like that. I don't know what the specific companies are that are working on the 2 projects, Veritas and Da Vinci, but you have places like Ball Aerospace that builds a lot of satellites and probes for NASA. I wouldn't be surprised if they were already working on Veritas. So.
Very cool. I think we have one last question from Kim. Okay. If there's lava on Venus, are there volcanoes?
Yes, and that answer is yes. There are lots of volcanoes on Venus, many. Good question.
All right. And I think that's it. It for our questions. So let me see. I'm going to, first of all, just thank you so much, Doug. And I do want to tell everybody that our next presentation is at 2, and it's 2021 in space exploration.
Cool.
And Skelly can drop the link in the chat. So that'll be a fun one. And then we have a curiosity update at 4. And the one I'm really excited about is at 6, a history of Mars exploration, because I like all those Mars rovers. And so
that's a great presentation.
Yes, it will be. And then, so I'm going to share my screen.
I'll stop. Do I stop my share?
Oh, you're not. Yeah, you.
Or can you take that from me?
I think you're not sharing anymore, so you're good.
Okay,
I just have to pull it. I just have to get mine all organized here. All right. So Doug, thank you so much. This has been such a fun time, and everybody's so excited about Venus, and I think that you made us even more excited about it.
Great questions from everybody too. Super questions.
So I do want to say we have Venus t-shirts. So if you fell in love with Venus today because of Doug's presentation, you can go to the museum store's website and get a Venus shirt or a hoodie to commemorate Astronomy Days this year. And I want to thank our sponsors, North Carolina Space Grant and Pepsi. And then I want to thank our museum members. Thank you so much for being a member and supporting the museum. Your membership helps put on programs like Astronomy Days. And if you are not yet a member, please consider joining. So as I said, membership supports all the wonderful things we do at the museum. So thank you, everyone. And we will see you later today, hopefully.
Bye, everybody.
Bye.
Bye.